Welcome everyone to this GC Tech Talk number 4 session. Usually they are moderated by Marius Feldman, which is CEO of Cloud&Heat, but unfortunately today he will be a bit late, so I will start this moderation and this introduction to the agenda. I think many of you will probably have attended other tech talks. So this is the 4th one. So I think for most of you, this is not the first one. But just in case, I will go briefly through the structure of the tech talks and then some information on the background, just so everyone has this information. So we have 2 presentations today. The first one is on how to create beautiful cloud-native landscapes by 23 Technologies, and then a second one on cloud services for Earth observation data exploitation by CloudFerro. Each presentation will be approximately 15 minutes, and then we have some time for discussions at the end. At the end of each presentation, so there will be one discussion following each presentation. And then we will provide you some more information about the next sessions. So just a brief background on the GC Tech Talk. So this is an initiative that we started based on a joint project that started by several German organizations a while ago to present a proposal to the IPCI call for projects, which started a while ago, well, a long time ago actually, working on this joint proposal. And then we thought that we had built a very, very interesting and very fruitful community, and that it was worth continuing these discussions and to open the format to other participants. So that's a bit of the background. And what we do here is we discuss, or different organizations present their projects that they have that are related to sustainable cloud services or cloud services for the next generation of infrastructures. Also the use cases that will use those services. And so that we can continue building a joint understanding of the landscape that we have. And the idea is to have brief technical presentations on a specific concept, on a specific implementation, challenges that are associated with that technology, and to discuss that. If any of you want to present a project, you have something that you think might be interesting, just let us know. There's an email there that you can use, techtalk@cloudandheat.com, and we will be happy to find a slot for your presentations. So yeah, just if you have anything that you think is worth sharing, just let us know. Very briefly, I sent a while ago an email asking you for your feedback on the tech talks. So we're collecting feedback on how to improve, on what's working well in these sessions and what could be improved. Our intention is that everyone who attends the session gets the most out of it. So please let us know if you have any ideas on how to improve the tech talks. And there will be a brief summer pause in August, and then we will continue in September with the tech talk. So just save the date, and you can mark it in your calendars right now. We will be using the same Zoom link. So with this, I think I would like to start the presentations, and so I will hand over for the first presentation to Lothar Gesslein from 23 Technologies on how to create beautiful cloud-native landscapes. So I will stop my sharing.
Well, actually, I think you cannot hand over to Lothar because he's not available today. He just got father, so he's not here, and I will do the presentation. I hope that's fine for everyone.
Yeah, sure. Sorry, I didn't have the information. I'm also with
23 Technologies, and I'm Jens Schneider. I need to confirm that the meeting is recorded. Yeah, and I think I can also give an introduction to Gardener, which is this multi-cloud Kubernetes engine we want to introduce in this tech talk. It's not a project by us, it's a project driven by SAP. And what we did is we built a lifecycle management and provisioning tool around it, so that it is installable, well, more easily, I would say. And well, I just headed here to the Gardener website, and what you already see is it's a managed Kubernetes service done right. And what I always like to start with is the overall architecture, and you can find that if you just go to the documentation of this tool, to Gardener, concept, and then architecture, because there's the very basic idea of Gardener already depicted. The idea is to run Kubernetes on top of Kubernetes. So what we actually have here, we have a Kubernetes cluster which hosts the Gardener control plane. So you can see that with this Helm symbol here. And then we have several other Kubernetes clusters below that, which are called seed clusters. So this is also kind of one of the key terms in the Gardener context. And these seed clusters also host Kubernetes control planes of so-called shoot clusters. And these shoot clusters are the end user clusters. So if you want to provision a Kubernetes cluster on any cloud provider's infrastructure, you will get a shoot cluster in the Gardener context, whereas the Gardener administrator will talk to the Gardener control plane cluster, which is up here. So, and you can already see that you will have more IaaS regions here, and you could have several seed clusters per IaaS region. And like this, a whole Kubernetes landscape will span over multiple seed clusters and then over multiple shoot clusters. But all of them are controlled via this Gardener control plane initial Kubernetes cluster, which is kind of a great concept, because we can use Kubernetes resources in order to control other Kubernetes clusters, which can be used by developers or by some providers of web services or whatnot you could imagine. So we also have a more detailed architecture diagram here, but I think this doesn't really fit into the demonstration I want to give in this tech talk. It will for a deep dive. So if you are interested, of course, we could also deliver more information on that. If you're interested, you can simply contact us and we can discuss offline of this talk. So what we did is we provisioned a Gardener, which is available, and you can find it on okeanos.dev. And if you click to sign up here, you can log in with your GitHub account into this public Gardener instance. So if I simply log in with my GitHub account, I end up in our Gardener instance. So of course, I will see in this dashboard, in this Gardener dashboard here, a few projects we have already set up for our own purposes, and projects are listed here in this drop-down menu. And I want to use the 23 test project for this demonstration right now. So what you can see here is that there are already some Kubernetes clusters which are provisioned. So one is also in a running state, the others are hibernated, so they are sleeping at the moment. I will get to that a little bit later, what that actually means. What I can do further is I can configure some secrets here. Secrets are basically, well, cloud provider secrets, because Gardener is a multi-cloud Kubernetes engine. We can provision, as I already told, Kubernetes clusters on more or less any cloud provider's infrastructure. And we have already secrets for the Hetzner cloud, for example, here for some OpenStack cloud and for the Azure cloud. And these secrets will then be used in order to spawn virtual machines on the cloud provider's infrastructure, so that the Kubernetes cluster can be spanned over these virtual machines. Of course, there's also some member management here and some administration, but I think this is less important for this session now. What I want to show next is how easy it is to provision a cluster. So I simply click this plus symbol here, and now I get a few configuration options. So what I can do is I can first of all select an infrastructure I want to use for my cluster. And well, I would like to get a cluster on the Hetzner cloud. Right now, this is just because of the Hetzner cloud offers the most, well, I would say the least expensive virtual machines. And then I can, of course, select a name for my cluster. So let's say test cluster. I can select the Kubernetes version. So I just want to use this 1.23.9 version right now. I can select some infrastructure details. I think they are not that important right now, but I can, for example, select between Calico and Cilium for the name type here. And what I also can do is I can also select some workers for my cluster. So this CX21, this is a rather small worker which has only 2 CPUs and 4 gigabytes of memory, and I could also select a real heavy one with 48 CPUs and 192 gigabytes of memory, but I think that would be well over-engineered for this demo, so I will stick to that very small machine here. I could also select the machine image and the container runtime and some other configuration options. So this is also kind of a very user-friendly interface for the configuration of the nodes which are running the cluster in the end. I could also, well, turn on some add-ons, but I think we don't need that at the moment. And here we get to a very interesting feature, which is called hibernation. So that is, well, I hibernate the cluster in some, according to some schedule. And for example, I could tell, well, Gardener here that I want my cluster to wake up every morning at 7 a.m. Well, I think I need to put a.m. here, and to be hibernated at 5 p.m. So let's say we don't want to stop working at 5, but at 6 p.m. and simply change that. And once all of this is done, we can hit create, and now our cluster will be created. So this will take a while, but yeah, well, roughly after 5 minutes, the cluster should be ready in order to, yeah, well, do some stuff for us. So now this would be a rather manual process so far. So it is interesting from the user perspective because you can simply click a cluster, but if something more needs to be done. And of course, Gardener comes with an API. And as I already told, this is a pure Kubernetes API because in the end, we are running Kubernetes on top of Kubernetes. And for this reason, we have next to this overview tab here, also a YAML tab. And what you can see here is that we have the same specification I entered in this user interface in a YAML file available. And we could also simply put that YAML file into the Gardener API server, which is basically running here at the root. And then also our shoot cluster will be instantiated and will be created for us. Of course, we will also find all the other configuration options I entered a few seconds ago, also in that YAML file here. For example, our hibernation schedule is depicted here, and for example, our networking type can be found here. Excuse me. So this is basically interesting because we can declaratively instantiate clusters like this. So if I would simply take this YAML, download it, there's also the opportunity to download that directly via a few buttons down here. And yeah, well, save it to some directory or maybe even to a Git repository. Then I can reproduce this cluster over and over again. So that basically brings me to the next interesting aspect of this introduction to Gardener. We could also monitor all these resources and all these clusters via the pure Kubernetes API, via K9S, for example. And I already opened the Garden cluster, which is hosting our shoot clusters in the end here in K9S. So what you can see up here is all the shoots in the Garden 23T test project. And what you already see is that this test cluster I created a few seconds ago is still in the create process here. And this is basically the same we see also again here. So we are at 82%, and here we're also at 82%. And this is really nice because I can control this cluster creation via a Kubernetes API call, and I can, well, basically, control it and monitor the overall process via my native Kubernetes workflows. So I could also do a describe on that one and see down, well, at the very bottom of this page, what is going on. And well, in the very, very beginning, there's always some warning showing up, and then it's starting reconciling, and the cluster is created. So this is basically the view of the clusters running, of the shoot clusters running in this dedicated project here. But as I mentioned in the very beginning, we also have these seed clusters, and these seed clusters are basically hosting the control plane for the shoots, as I already told. And I also want to show that. So for this, I need to switch the context here and need to select our seed cluster here. And now let's see whether we can find find the namespace for our test cluster, and that should be that one. It's 4 minutes old. And if I just enter this namespace, I see pods running here. And for example, you can see that here is a Kube API server running. There is some other things running. Of course, here's an etcd running. So here's basically the control plane. The control plane of the shoot cluster lives in that C cluster. And what we also see is that there are some Gardener specific components running. For example, the Gardener Resource Manager. This is basically a component managing resources in the C cluster, but also in the shoot cluster. So we could make sure that, for example, some pods are always available in the shoot cluster by managed resources, and the Gardener Resource Manager then will take care that these resources are reconciled correctly and that they are always available. So we also see some other things going on at the moment. There's Prometheus starting up, for example, and I think the cluster may be provisioned already completely. Yes, we see that our cluster is already created. And what we can also see right now is that we got another tab here, which is giving us a kube config for this cluster. So we could download it and directly start developing or doing some other stuff, what we would like to do. So now this would be the user perspective and also the operator perspective. The user perspective from the dashboard, the operator perspective here from the Kubernetes workflow in K9s, and monitoring all these resources and so on and so forth. But this is not all of it yet, because Gardener also offers the opportunity to write extensions for it. So, for example, there are a lot of extensions realizing all these provider options I've showed in the very beginning. So every single provider here is implemented by an own extension. So if you, for example, want to support a totally different cloud, which is not available yet, then you could go ahead and write your own extension, which is introducing the infrastructure of another cloud into the Gardener ecosystem, and you can simply provision then Kubernetes clusters on this other cloud infrastructure. So I think this is a really great feature, because Gardener is somehow solved with openness in mind. So you can really have some great extensions to it. And this is also something we already did. So basically the Cessna Cloud extension is coming from us, so from 23 Technologies. We just did that because of, I already told it, because of the expenses having less expenses for our development clusters, for example, or for having CI/CD clusters, which are less expensive than Azure clusters, for example. And we also did that with other extensions. For example, we implemented the Gardener extension shoot flux. And this is basically an extension which provisions a Flux controller. Flux is a GitOps operator for Kubernetes directly into shoot, so into end users clusters. So what you can do with that is you can simply define a state of the cluster you want to have in the end in a Git repository, and when you create a new cluster here, it will be reconciled to the state you defined in the Git repository. So this is kind of useful if you want to have some preparation of your clusters, for example, for CI/CD workflows or something like that. So I think that was all I wanted to show in this very limited amount of time. And I really would like to open the discussion as soon as possible, because I think Q&A sessions are, well, more fruitful often than just just having plain input. So thank you for your attention, and I'd like to answer any question you throw at me.
Yeah, thank you very much. So I jump now in here. So Maria started the session, but she seems to have some issues currently with her laptop. So I briefly take over. Yeah, are there any questions?
Yes, I would have a question. My name is Jan Nowacek from FTLI, and Thank you for the introduction to Gardner. I would be interested in to the aspects regarding Gaia X, and there is my question with regard to the conformity of Gaia X. What else would be required, and how does Gardner fit into the Gaia X vision?
Well, actually, I'm not that involved in Gaia X, so I cannot answer this question. So if you would like to know more about that, I suggest that you contact us once again, and then we can make sure to answer that question. But I don't want to just guess something right now. That doesn't make sense.
Okay, thank you. So then I will contact you again. Yeah,
well, just send me an email and we can set up another meeting. And well, some of my colleagues definitely know, so then we can discuss about that.
All right, thank you.
So other questions?
I could maybe very briefly take over to answer as well that question. As well, we are also a little bit involved into Gaia X. So I mean, actually, Gaia X is about standardized self-descriptions, identity management, and interoperability between or among cloud providers. And so there is not a very strict relation, actually, on one hand. As well, in the end, it does not matter which technology you use as a fundament for your cloud infrastructure in order to be Gaia X compliant. So Gaia X is not limiting anything there. However, well, Kubernetes itself may help in general to promote and push forward interoperability. So in regards to the overall vision and idea of Gaia X to foster interoperability, I think, well, Kubernetes itself may help. However, as mentioned, there is not a very strict relation here.
Oh, okay, thank you.
Michael, you have a question.
Yeah, please. Looking for multi-cloud support, could you please give us a word, if it's possible, let's say, to orchestrate different clusters that are serve the infrastructure from different cloud providers?
So you mean that one cluster, well, one cluster is sharing infrastructure over different cloud providers? Did I get that right? Or
Yeah, for example, so let's say I use Gardener, as you showed us, to orchestrate all my clusters, but for different clusters, I'm using different infrastructure as a service. Is that thinkable or possible, or is it too complex? What do you think about this?
Well, I'm not really sure whether I get that question right, but if you have different clusters, then you can choose your infrastructure for everything a cluster. So that doesn't really play a role here.
Okay, so
or do you, yeah. I'm not entirely sure whether I'm getting your point.
Yeah. Yeah, if you don't mind, I would like to pick up your contact data and then to discuss this afterwards. So I'm interested.
Yeah, of course.
Yeah,
just go ahead. You will find me on GitHub. You will find me. Well, you will find us via 23technologies.cloud.
Okay, thank you.
Yeah. So another question, Stanislav.
Thank you. Stanisław Krzyżanowski, CloudFerro. I would like to ask you about, well, what's coming next in the context, especially in the context of Cloud Edge Continuum that is actually bringing us all here. Are you seeing a possibility, or maybe you're planning to go beyond integrating or allowing, let's say, something apart from more traditional cloud infrastructures to be leveraged with Gardener? So let's say, are you planning to make it more not only IaaS cloud agnostic, but type of infrastructure agnostic?
Well, Actually, I think this is not entirely up to us, because as I already said, Gardner is not mainly driven by us, and we are, well, more or less focusing on the part on making it installable and managing the life cycle of a Gardner. So this is basically what we are working on, and building CI/CD pipelines around it, and while making sure that the overall system is capable of running and hosting multiple Kubernetes clusters at a time, and making cluster management easy. So I think this question would more or less go into the direction of the SIP developers directly, and not really into ours. We are not planning to develop an extension like this at the moment. So if that helps.
Okay, thanks.
So maybe I can also stop the share.
Yeah, any further questions? If not, that was good timing. So 2:30, exactly half an hour. Yeah, Jens, thank you very much for that presentation and that overview. And now, yeah, just
I can try.
Yeah.
Yeah, I hope that you can hear me. I'm sorry, I'm having some problems with the laptop. But now we have the next presentation from CloudFerro. So Stanislav will do the presentation, and it's on exploitation of Earth data observation.
Oh, okay. I assume that you can see my screen and you can hear me. Is that correct?
Correct, yes.
Splendid. So thank you very much for organizing this tech talk, and thank you all very much for your time and attention. My name is Stanisław Krzyżanowski. I'm with CloudFerro, and today I would like to tell you how we leverage and develop different existing cloud technologies in order to bridge the gap between technological gap between Earth observation data and its users, and how we use it to facilitate different, let's say, user needs, less technological, but less technological requirements with a very technological solutions. But first of all, I believe that I owe you a bit of introduction of why I am speaking here, and why it might make sense what we present. So CloudFerro is a Polish company. We are an SME, a European one, providing cloud computing services, especially for the European space industry, especially focused on the Earth observation data. A lot of Earth observation data, as it will turn out soon. We are currently in 4 European countries, three countries in the EU. And throughout the last 7 years, we have built a number of different cloud platforms that help in storing, managing, disseminating, processing of Earth observation data and its derivatives for major European players, using a set of principles and the certain approach that I'll be talking today about. But at first, I need to say just a couple things about Earth observation data and what's that, where is that gap, and why it exists. So first of all, the Earth observation data is any satellite-based in our case, any satellite-based observations that make it to Earth. And the gap that I'm talking about appears between data generation and users and entities that might want to leverage that data and process that data. The gap exists due to huge quantities of that information. We're talking about petabytes of data, terabytes of new information generated daily. So it used to be quite difficult to tackle that on your own as a company, for example, interested in building applications, or as a scientific or research unit interested in analyzing that data to gather some useful information from it to build any added value. So that's the technical problem. The quantity, also quality, and the required throughput and computing power to leverage Earth observation data in your value chains. But also, we need to encompass different stakeholders that are involved and take their needs into account. We are talking about 3 distinct groups. Those are policymakers and /society. Usually in Europe, these are the stakeholders who fund the whole enterprise. Then we have users, so those who are interested in the added value, and data providers, so some commercial entities that generate the data, either from the satellites, or they process the data into higher levels. And all those groups might be interested in different data consumption models, from the very basic of just viewing type. Somebody is interested in how their neighborhood looks like from the top, up to advanced let's say batch or systematic type processing using Kubernetes clusters. And in order to meet all those technical and functional and social requirements, we have came up with a solution. You can see a high-level architecture of our solution that consists 4 major components. The first one is the EU data repository and catalog, and surrounding tools for data acquisition and data dissemination. Because what's difficult here is we're talking about the tens of petabytes of data. In terms of number of products, we're talking about hundreds of millions of products. So it's difficult to start, it's difficult to index, and it's really difficult to disseminate. So apart from only storage, we have tools for data discovery based on our in-house cataloging service, and together with an search API based on OpenSearch protocol. We have tools for data access, that being depending on the type of requirements and type of users that can range from visual, let's say more visual type web app service format that is generated on the fly upon user request, through formats or not formats, through types of access more suitable for single downloads, such as HTTP, up to S3 protocol used for massive data interactions. The next component that we designed and we provide as the cloud services component, it's on one hand a set of more generic cloud services based on, it's all based on open source solutions. We build our cloud services on OpenStack. So we deliver computing in form of mainly virtual machine based processing, but also recently we focus more on product generation in either function as a service or batch type of processing governed, which is governing a Kubernetes cluster scaling on user demand, or in case of systematic processing. So systematic processing meaning something that we do daily or weekly with the new data incoming. Together with number of storage solution, proprietary storage solutions. And the third important component of our approach is the, let's call it front end, a number of web portals and applications that allow our users and let's say less tech savvy users who might not want to use only API to interact with the data, interact with the cloud environment, and browse through any knowledge they may require. And this architecture has been used and is being used and developed, currently developed for all our platforms, those I've mentioned previously. And what are the principles that stand behind how we do it? First principle, which might be quite surprising, is to store almost everything that has been observed or has been generated. Because in case of the Earth observation data, the acquisition cost, especially when you take into account the investment cost, is relatively high. In our estimate, we've made some estimations. So to acquire a single product is probably 10 times more than it costs to store it for 10 years. And it's, as it turns out, it's also much cheaper to store data than to generate it. That's why we end up with tens of petabytes of data. It's I think it's over 26 petabytes of data currently, because we believe it makes more sense to store it. And when we generate data either in a systematic way, or when we generate data into some standardized higher level formats, we also store it, even if it's on demand data generation. And with time, we are learning that it really makes sense to generate almost everything that we can. And then, in order to make that data useful, to actually allow third parties to create information from the data, we keep it in uncompressed formats, because Earth observation data is usually, a single product is not a single file. It's usually a more complex tree of files with different applications requiring different parts of the product. It makes sense to store it in an uncompressed, immediately accessible form. Together with an API and a number of access methods, it allows us to disseminate roughly 10 petabytes of data every quarter, at least recently. Next, of course, yes, there is a requirement to have processing power to accompany it, and scalable bandwidth. And here comes first mention about what next steps we may. I need to be quicker. What next steps we may see with more and more platforms of for Earth observation data popping up. We believe it makes sense to federate them and incorporate them together. So it makes sense to optimize federating users and data access, because it doesn't make sense to keep more copies. We are working on joining many platforms together, and especially creating common catalogs with references to multiple data sources. And together with those catalogs, we are offering those homogeneous interfaces. A good example of that is the Cloud&Heat platform that can source data both from, let's call it German repository, and from the Warsaw repository. We are all doing that while using and contributing to open source projects, because we want to create a more, let's say, global uptake of this, not global, but the bigger uptake of this technology. We leverage OpenStack for cloud management. We leverage TEF for storage. We leverage Keycloak for user management and identity management, and we are trying to contribute to open source more and more with time. So it all leads us to actually saving energy and resources, because we use effective storage, and because we optimize between different storages and different platforms, and because of how we build our hardware with large HDDs, with different types of storage, with erasure coding, we require less resources. And what's next? Currently, we have a number of platforms that are built with a same philosophy in mind, using a same concept. And for the next steps, we see a greater federation of data, resources, and users between different platforms, also from external providers. We want to leverage renewable energy more and more. Also, in terms of using edge nodes incorporated into the system, and we want to expand from only EU Earth observation data to all spatial data within the next years. Okay, that I think would be it. Thank you very much.
Okay, thank you very much for the presentations. So are there any questions or comments from the audience? Yes, Michael?
Yeah, hi. Semantic layers. So which kind of semantic are you looking for? Do you have any made any decisions, or?
No, we didn't make a decision yet. However, it all comes back to making data more easier to discover and easier to use. Currently, all metadata can tell you is when was the product acquired, how it was processed, some information about the platform which acquired the product. There is no actual information about what's in there. So first thing that we would like to get from semantic layers is basic information. For example, how much water is there, how much snow is there, how much something is there, because then we can allow our users to discover, for example, products with lots of snow. It's a very, very primitive example, but I hope it goes through. Next steps would be to incorporate, let's say, more intelligent semantic layers. So there is a possibility, we can have an ability to draw conclusions, for example, from changes between different products covering the same area. Did I get your question right?
Yes, absolutely. So thank you very much for this. So I just wanted to feel how far you are. I mean, this is an ever told story, isn't it? So
oh yeah, it is. It's a goal, but it's a goal that we will not achieve on our own, and we're always looking for good ideas in here. Yeah.
So thank you very much.
Thank you.
Thanks. There's another question from Josep. Can you hear us, Josep? Okay. So any other questions? Yes, Jaime.
Hi, Stanislav. Thanks for the presentation. Sorry, put here my camera here so you see my face. Very interesting. I'm actually more a physical guy, so I'll ask a question about the physical part of your business. So you talked about federation of users and data and so on. So my question is about what kind of physical data centers do you use? If the redundancy is maybe more ensured through this federation, well, at the end, how do you ensure that redundancy of your data?
Okay, so correct me if I go in the wrong direction with my answer. So what we do currently, as I said, we are using something called Ceph to store the data. It can use both SSD disks and HDDs. We use HDDs currently because of the cost efficiency, and there is no requirement for throughput that would drive us to use SSDs. So we locate. We have some principles as to how the replication works, that you cannot keep all of the copies of a single product within the same node, but the nodes are still within the same data center. And additionally, when we are deploying new platforms, we may select together with the client or on our own what data should be copied and kept in another location, for example, with a private cloud in another location. And the idea is to interconnect them using high bandwidth. It's usually 10 to 20 gig. Did I get your question right?
Thanks.
Welcome.
Thanks. So, Josep, do you want to ask your question now?
Yes. Concerning high bandwidth, we are considering using 100 gigabyte connectivity. Then in that environment, I think it should be able not just to connect to remote sites by things like S3 bucket, but directly, for example, with NFS. This will save a lot of storage space. Do you think it's feasible now or in the next years?
In the future, in the next years, yes. however, with even having this kind of a bandwidth, there is a still limitation on the software side. So just to put it simply, the current capabilities of the catalog indexing tools and storage software might not be up to par with 100 gig connection.
Okay, thank you.
But ideally that's the goal. The highest we've done some testing, and the highest amounts of data that we were able to disseminate, to transfer, was, I think, was it 2 petabytes daily? But that was purely experimental for now.
Okay, thank you.
Welcome.
Okay, I think we have maybe time for one more question, if there's any other question from the audience. Maybe then just a brief one from my side. You have mentioned different topics in your presentation that are part of your service or of what you're doing. But what is, from your perspective, the greatest challenge? It's also related to the question that was being asked before, but what is now the greatest challenge to make this all this data really exploitable?
It's the challenge is twofold. On one hand, the challenge is to incorporate other types of data. So you always require more information than only Earth observation data when you want to build an advanced application for, let's say, for example, city monitoring or environment monitoring. It's always good to get more information. So connecting different data sources and incorporating, creating common catalogs, common indexes is a great challenge. So that's one part. That's one part of the challenge. And the second part of the challenge is to assure not only sufficient computing resources in terms of quantity, but also in terms of geographical location, network topology, and specific both security and legislative restrictions. Some very sensitive applications may require the execution of the application be done in a very certain place, and so this basically means that we need tools for, a bit similar to what our colleague was talking about before me, tools for platform agnostic resource management and processing management. Those are two big steps for the next 2 years, for the next couple years.
Okay, great. Yes, it sounds in fact like big steps. Okay, thank you very much for your presentation. And now we have 2 minutes left, so just let me close this off by sharing again my screen. 1 second. So again, just a brief reminder to please fill out this survey to provide feedback on the sessions. I think I can send it again right now after the session in case some of you don't have it. And as we were saying before, there will be summer break in August, and then we will continue in September, the 29th of September. It's always the last Thursday of the month. And these are the two presentations that we have planned for September. The first one will be on Swarm Learning by Hewlett-Packard Enterprise, and the second one will be on providing basic digital services based on Green IT and for critical infrastructures. And they will be presented by Energie Baden-Württemberg. So save the date, and we will send more information as soon as possible, so so that you can have the invitations in your calendars. And yeah, fill in the questionnaire, please. And otherwise, have a great summer. And we are looking forward to seeing you in September. And thank you very much for the speakers again. Very interesting presentations.